Good morning, children. Continuing with the chapter Force and Laws of Motion, we are doing today the Newton's second law of motion. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force and it is inversely proportional to its mass. It means that if acceleration is more, if you apply more force on an object, it will accelerate more. But it is inversely proportional to mass, that if the mass is more, the acceleration will be less. Yes, children, see this figure, everyone, that there is a trolley which is being pushed by a person having a mass kept inside it. He is applying force on this trolley. And you can see, children, by applying force, he is applying the force and the speed of the trolley increases, due to which it moves from its position. In the second figure, children, you can see he is applying more force. The person is applying more force on this trolley, and due to which the same trolley it is, but he is applying more force on it now. Now it is showing more acceleration and its speed is increased. So what does it show? That more the force, more will be the acceleration. Less the force, less will be the acceleration. Yes, children, please see to it again. This is next. That how a ball of different masses is being pushed by two different persons. The ball having a mass of 400 kg. He has to apply more force to accelerate it, to move it. And the person pushing a ball of 40 kg, same person, he has to apply here the less force to push it. Because what? The mass is inversely proportional to acceleration. If the mass is more, the acceleration is less, because you have to apply more force to change its position. Yes, children. So Newton's second law of motion states that the rate of change of momentum of an object is directly proportional to applied force in the direction of force. This is second law of motion. Now you people, you have already seen that in the first law, we have read that first law indicates that when an unbalanced force is applied on an object, it shows acceleration. Its velocity changes. But if the second law of motion states that we have to find it out, that how acceleration of an object depends upon the force applied on it. As we have shown right now, that more the force applied, more will be the acceleration. Okay, now so many examples we come across in our daily life that I'll tell you right now. But before that, you should know what is second law of motion state. What it states, that rate of change of momentum of an object, it is directly proportional to the applied force in the direction of force. Now we have to mathematically formulate the second law of motion. Now, if we say that there is an object whose mass is m, and the object is moving in a straight line with some initial velocity, we say that it is u. You can see, and it is accelerated to v in time t. Then the force applied is directly proportional to its rate of change of momentum. So what is momentum first? Momentum is the product of mass and velocity. So if we say that the object is moving with the initial velocity u, then in that case, its momentum will be mu. And because its velocity has changed from u to v by applying a force in time t, so final momentum becomes mv. So what will be the change in momentum, children? It will be mv minus mu. And with respect to the rate of change of momentum, when we write with respect to time. So it is m into v minus u upon t. And when the second law says that rate of change of momentum is proportional to applied force, we say that force is directly proportional to m into v minus u upon t. Now to remove the sign of proportionality, we put the sign K. We put the sign K here, children. So F is equals to K M into V minus U upon T. From the first equation of first equation, we have read that V minus U upon T is what? It is equals to acceleration. It is the rate of change of velocity. So instead of V minus U upon T, we can write A. So F is equals to, yes, children, F is equals to KMA, where K is the sign of proportionality. If, for example, we say that the object has a mass of 1 kg and it is showing an acceleration of 1 meter per second square, then force is equals to what? It is equals to K, that is equals to Newton. So the symbol of the Newton is, the symbol of the force is Newton, which is represented by N. So second law of motion is F is equal to ma. Yes, children, as we have told you right now, some observations that we come across in our daily life. During the game of the cricket, have you seen the fielder is pulling his hand backwards? You must have seen that for catching the ball, cricket ball, fielder pulls his hand backwards. Why he pulls his hand backwards? There is a reason. There is a scientific reason behind it. The reason is, you can just see to it, children. A fielder pulls his hand backwards while catching a cricket ball to reduce the momentum of the ball, as the ball has a large velocity. So due to large velocity, if he catches the ball there only, the momentum will be reduced to zero within no time. Instantly, the momentum will be zero as the velocity will become zero. So to increase the time and to reduce its velocity, what the person is doing? He is pulling his hand backwards to catch the ball so that he does not hurt on his hand. This prevents the hands of the fielder from getting hurt. This is a very common experience which you just see in your daily life. Second experience, you can just feel this application, that whenever the athletes, they are doing long jumps or high jumps, if they are just falling on a sand bed or cushion bed instead of cemented bed, do you know what is the reason? Again, the reason is the same. If they are falling on the cemented bed, immediately their large velocity will be reduced to zero instantly, and they will hurt more on their body. And to increase the time, and so that they reduce their velocity and they hurt less, what do? They fall on cushioned bed or sand bed, so that on falling on it, their velocity does not changes to zero immediately. To reduce the momentum of an athlete to zero, what happens? The time is increased. And when the time is increased, what happens, children? For increasing the time, the momentum is changed and they hurt less on it. Yes, children, they hurt less, and due to which they fall, they easily they can just play this game for moving. Okay.